Another factor that the resonance phenomenon and the standing waves have are called as Chladni plates. This guy, he was German, and he was a physicist and a musician, of course, and he did a lot of work with vibrating plates and how standing waves are created in 2D. And I will show you an example of those. He actually did work like this with the bow, but that is very, very hard to do because you really have to know your frequencies. And it's going to be fascinating because with every frequency, your plate will vibrate differently and it will send spots of hot. So remember how the standing wave patterns look like this? So if you put salt or sand on top of a plate, where do you think the sand will collect if this plate starts to vibrate? Will it collect at the highest points or the lowest points? Take a wild guess. There's two choices. Highest or lowest? Okay, so that is a great idea. So where do you think the most vibration will be in the plate? The plates where there is highest vibration, right? So will sand want to collect there? Where will it want to land? At the points of the, like it'll be like a valley. It's going to get into the valley. And the fascinating thing is that once it gets into the valley, you know that the difference between the two valleys will give you the whole standing wave. Oh, and then every plate will have a different reaction to the different frequencies. So I'm only going to show you one plate. Are we ready? Let's see if I can. So watch as the patterns become more and more complicated as we go to higher frequencies. Can you guys hear that, or is it all directed towards me? Did you see those become more and more complicated as we kept increasing the frequencies? The points where the sand was collected are now the nodes, whereas all the other points are like a valley. So the standing waves are in between where the nodes were. Okay? And so how does that help us? It helps us when we have to figure out what the response of our instrument is going to be to the different frequencies. And guess where they put the bones, the material? At the nodes or the antinodes? The nodes. And imagine how complicated that becomes, because you don't play one frequency, right? You play many, many, many frequencies. And that needs to be determined. So this particular picture shows you where the sand is landing, this is where the nodes are for this instrument. And this is a different frequency that is showing you. This is where the node is for that one. Now you have to figure out, that's why these musical instruments cost so much. Because not only does it depend on the wood, the type of wood you use, but where those bones are placed, where the structures are placed for stability and strength. So in a guitar, those patterns generally correspond to these. Okay, same thing you could do for a violin. Your patterns will be this corresponding to a particular frequency, this corresponding to another one, this corresponding to another one. So all of these red marks that I'm showing you, are these nodes or antinodes? Nodes, remember that. So the nodes are the points of the least vibration. That's the valley that everything connects in. Okay? Good.